start today the different functional forms of regression model. So what we have discussed how regression analysis is done between the dependent and independent variables. So now we'll discuss different algebraic models which will depend on the nature of data and their relationship. So the dependent and independent variables are related each other, and it takes the form of the model based on nature of data and the type of relationship that the dependent and independent variables maintain. Now, these algebraic forms are of different types. So models may be linear models, so the y and x, that means dependent and independent variables, are so related. Data are such that the models may be linear, it is a straight line, or maybe non-linear, then log linear, and semi-log linear, and reciprocal models. Okay. Now let us discuss one by one the linear models. So when you say linear, that means the change with additional application of x variable or a level of x will give the constant change in y, that means in the dependent variable every time. So it is y is the function of x, the dependent variable y depends on x variables. So it is alpha plus beta x plus error term. Now slope is the beta, as the beta is the slope of the line. It is a straight line because the maximum power of x is 1. So beta is constant. Now if we see the diagram, that it is a straight line, alpha is the intercept, and with every change of x, every 1 unit change of x, y will change in a constant way. So that means delta y or delta x is constant. Then second is a log linear. So log linear, so log y is equal to alpha plus beta log x plus error. So it is also known as the power function. Now Ln, which is natural log, it is the natural log. So beta is also the elasticity. So when it is a log linear, we can express it as y is equal to alpha x to the power beta. In production economics, we call it CD function, Cobb-Douglas function. So beta is the slope of the line, and it is also the elasticity between x and y. So we have already discussed this. So beta is elasticity. It is common when a relationship is proportional. So beta into 100 is the change. Then number 3 is semi-log. So semi-log is equal to log y is equal to alpha plus beta x plus error. So in this case, the dependent variable is expressed in log, not the independent variable. So it is commonly used in modeling exponential growth. So when we were to examine the exponential growth, then we generally use the semi-log functions. And how it will be estimated, how alpha and beta will be estimated, that we'll have to take the log of the dependent variable and log of the data of the dependent variable and x variable without log. So then we have to estimate the coefficients, parameters. Then number 4 is linear log functions or log model. So y is the function of log x. So just you see, now semi-log, when it is a semi-log, we take the log of the dependent variable. When it is a linear log model, we take the log of the independent variable. So this is equal to y is equal to alpha plus beta log x plus error. So data should be arranged as y data, data on y, dependent variable, and we will have to regress with the log data of the independent variable. So effect of larger level of x decreases the level of y. So characteristic is that if we use larger and larger level of x, so it will decrease the level of y. So 1% change in x leads to beta by 100 units in y. So this is the characteristics. So next is polynomial model. So y is equal to alpha plus beta 1x plus beta 2x squared and so on up to plus beta k x to the power k. So there will be any power according to situation. So it is generally a curvature and flattened polynomial. So we come across mostly two types. One is quadratic and other one is cubic. So quadratic functions. So y is the function of x, and it is alpha plus beta x minus cx squared. So it is a curve where it is increasing at decreasing rate. So it is a quadratic. Then another one will be alpha minus bx, beta x plus cx squared. Means it is declining, then it is increasing. So two kinds of, this is a quadratic form where maximum power is 2. Then cubic form, in cubic form, there will be 3 terms. Y is the function of x, so y is the dependent variable, x is the independent variable. So if we go on increasing the level of x, and there will be 3 terms. So first one, this alpha plus beta 1x plus beta 2x squared minus beta 3 x cubed. So first one, it is increasing at increasing rate, then it has declined. Okay. Then the second one, second one, it is increasing at decreasing rate. Then it has started increasing. So after some point, it has increased more faster. So this is the second one, and this is the first one. And point K is the point of inflection, when it has increased at increasing rate. After this point, it has started declining. That means increasing at decreasing rate. So this kind of quadratic cubic functions are quite common in production. So this is the non-linear. Then reciprocal form. Y is the function of 1 by a reciprocal of x. So alpha, this is alpha plus beta 1 by x plus error. It has limits. So best example is the Phillips curve. So it increases in efficiency, then leads to diminishing returns over time. So in case of Phillips curve, what Phillips curve indicates is that it relates a rate of inflation with unemployment. So when unemployment is low, the rate of inflation is higher. Unemployment rate is low means employment is higher. When employment is higher, naturally, more wage will come to the labor class. As a result, it will increase their buying power, and demand will increase for the commodities. As a result, inflation will rise. But it will have some limit, asymptotic. It is called asymptotic. That means after some time, suppose it is declining. After some time, after a particular point, it will move as parallel to x-axis. So this is y and this is x. Similarly, it will have limit in rate of inflation also, because inflation cannot be indefinitely high, and unemployment cannot be indefinitely high. So after some time, it will be asymptotic to y and x-axis. Then Amsel's curve. So generally 3 types. The normal goods curve slopes upward as income increases. So when income will increase, the curve will slope upward, generally of this type. Then inferior goods curve slopes downward as income increases. So when income will increase, generally demand for that inferior goods will decline. As a result, the curve will slopes down, and consumers, buyers, will try to seek some substitutes instead of buying the inferior goods. That's why it slopes down. Then in case of luxury, curve is concave. So this is the luxury goods, this is for luxury goods, and this is for necessity goods. So it is a concave curve, and consumption remains stagnant till an income threshold is met repeatedly. So for example, say high-end jewelry. So when income will go on increasing, so they will demand more for high-end jewelries. But after some time, it will decline or it will be stagnant. So, with this, we have concluded. And thank you very much for watching these regression models generally we come across. And please share and subscribe. Thank you.